I want to briefly draw some comparisons between what we've done today and what you might see in a language like Python or in real Java code. So today we've seen that the A-list and S-list class that we built earlier can be we can annotate them as implementing this interface list61b. And in that case, we could then manipulate the list with methods like add, last, and print. And it's similar to what you might see in a language like Python, where L is initially an empty list. You append some items, and then you can print it out. Okay. Now, if you've never seen Python, okay, maybe this is a little mysterious, but Java, the thing we built in Java is similar to what a Python list looks like. Okay. Now, this is a great improvement over where we started the semester with Java, where we didn't have any kind of expandable list. We were just stuck with arrays. Now we have ways to conveniently build data structures that start empty and then can get longer. Now, of course, real Java code doesn't use list61b or A-list. And in fact, the Java language designers have provided implementations of a list-like data structure in the form of an interface called java.util.list. So this is what we've built from scratch, but in the real world, you would use java.util.list, which simply has a method called add rather than add last. And if you print out a list, well, there's some clever stuff that it does so that it prints out nicely instead of having to have a special purpose print method. And we'll talk about some of that in a few lectures. Now this on the left is an interface just like the one we had. You can't instantiate a list. So if you want to have a list, you have to instantiate a specific implementation, java.util.ArrayList in this case, but there are others. Now, one of the convenient things about the list interface, other than the fact that it already exists, is it has a lot more methods than the one that we created. So it has an add method and a get method, but it also has many other things, like a special method that tells if a list is equal to another. It has this method called of, which is somewhat mysterious. It's got a remove method. It's got size, it's got sublist, and many other things that it can do, like create arrays corresponding to the current list. And one thing that I'll encourage you to do throughout this class is go out there, and if you're using the real Java interfaces, like experiment with these methods. The documentation is generally fairly easy to read, except for these sort of strange generic type signatures, which we're not really going to go into. But you should be able to get the gist of it and figure out how to use these methods. And it's a really important skill to be able to dig into documentation like this. The other thing I'll note actually is that in the top of the documentation for the list interface, it also lists a bunch of specific implementations. So for example, array list, which is like an A list, or linked list, which is like an S list, but with backward pointers. Okay, so like a doubly linked list. That's what the linked list is based on. But it also has other kinds, like an attribute list, whatever that is. I have no idea. Stack, vector, and these are all different ways that they've implemented list for different purposes. Now, one more thing I wanted to mention is that in real Java code, you do not want to write java.util.list. And so just like we saw in the testing lecture, if we include import statements at the top, we don't have to use the full name, java.util.ArrayList. We can instead just say ArrayList. And this basically what this import statement does is it tells the compiler, anytime you see ArrayList, what I actually mean is java.util.ArrayList. Now you might say to yourself, why would anybody ever write code that looks like list integer L equals new ArrayList? Partially it might be a thing of aesthetics, right? Like I don't really care that it's an array list, so I'm going to store it in a list variable. And because of the magic of dynamic method selection, I know that it's going to be calling the right method. But another argument you can make, other than just that aesthetic argument that the list is, I don't care what kind of list it is. The other argument is you might have methods, like maybe a helper class called utils that reads a bunch of integers from a file and gives you back a list. In that case, you might not really care what kind of list it is. And so this method likely just returns list, like that's its return type. And so in that case, you would need to, on the left-hand side, have the appropriate memory box. Okay. So bottom line, what we've got here, the things we built, A-list, S-list, list61b, they are reflected in real Java code, and you're going to be using them all over the place for the rest of this class.